Okay, everyone. I'm glad to see here so many people and familiar faces as well. I guess most of you came to understand what's going on with Guido, but I'll be talking on Python 3.8, the new stuff in it, obviously the assignment expression, and let's start. First, for those who don't know me, I'm a serial entrepreneur. I'm involved in educational projects for diversity population. These are Arabs and extreme religious people, Haredim in Hebrew, and integrating them into the high-tech companies and software industry. And I've been doing Python like over 20 years and very active within the community. The 3.8 is going to be released on September. That's the release candidate. If you want, you can still use the alpha. And I think soon the beta would be released. It should have been released on end of May. It wasn't yet. Possibly today or yesterday, I didn't check it. But there are new features which are interesting, and I think you would like to see them. So let's move on. PEP 572, who was here in yesterday's presentation by Tal? Okay, most people. And you heard the story about this famous or infamous PEP with assignment expression that was interesting. So what it's all about? Spoiler, it's very simple. The ability to have some expression and assign it to a variable and still use this variable next on, because we assign and continue using the assignment as expressions. So why do we need it? What's the rationale behind it? First, it's more readable in some cases, and I'll show some examples soon. Very simple. We can see this and understand the code easier. This is something that we already have in assignment statements. We can have 2 or 3 variables assigned at the same time to the same value. So this is basically the normal assignment we have. This enables us to reuse sub-expression or some calculation, and it has advantages when we debug code. Sometimes in debugging we have to break down expressions and refactor the code so we can see some part of it and debug it and understand its value, because it's very complicated to understand the entire calculation. So these are all advantages, and the PEP was discussed how to do that. Let's see some examples. So first example you can see is some bad smell. I guess most people can see that we calculate the match twice. This might be expensive or not expensive, but this is a pattern going on, and most examples are from the PEP itself, and you can see some of the examples I'll show are actually from the Python library. So in this case, we have the same calculation done twice. One, to understand whether there is a match, and the other, once there is a match, to use it. And using the code should have been like this. And somehow some people do it and some people don't. And maybe they don't care because they think there's a very little cost associated with the calculation of a match. That might be the case in some cases, but not necessarily in all cases. So let's see what assignment expression would do. You can see here that we can use a match in the if clause, take the result, and use it to calculate, to take the first group. So basically we calculate something, take its result. And you can also see the syntax, which is colon equals, which is different than the usual equals we use in assignment statements. Okay, so another example is that we can add the search in an if clause and use it later on in another statement. So the first one above is using it within the same statement or expression. And the second one says, okay, I have here some if statement. In it, I get some of the results of the expression. I save them in a variable, and I reuse this variable later on. Instead of, let's say, doing the calculation first, using the variable in the if statement, and later on using it. So it does simplify the code, and the idea was to have something which is very readable, very easy to understand. I guess this comes familiar for people coming from languages like C and C++. The usage of the result of some expression in a loop and then moving on and processing the same data only when it's valid. If it's not valid, we use the same value to exit the loop. So this can now be done in a similar way in Python. Also in comparisons, we can use them to take the value and use it again and again inside the comparison, which again simplifies the code. I don't know if you're aware, there are a lot of advantages for readability and performance to use comparisons. So this is again a way to do that, either in the if clause of the comparison or directly as one of the values. So now I move to some examples from the Python standard library. You can see in a file called site.py an example where code could be simplified, still very readable, still very easy to understand, using the assignment expression instead of the usual way to do the stuff. We're using a variable and then rechecking it. So we do that combined, and still the code is very readable. Another one from PyDecimal. Again, you can see something which is kind of long to read and shifts to the right because we have an if and then another if. And this can be done in a single liner. Again, without losing readability. The idea is not to make stuff shorter or just easier to understand. It's, again, the idea is to make it more readable, more easy to understand. So that's another example. You can see here the result of it, very simply done. It's very easy to read. And another from daytime. Again, you can see it, the variable is used to be an if, and now it's a very simple addition statement. Last example for those who fork, there's a simple way to do that. Tim Peters, I guess most people know, one of the co-developers, did have a look inside, and you can see in examples, he made a lot of examples. He said he showed some cases where using assignment expressions would be weird or inappropriate, but he showed a lot of cases where it makes a lot of sense and simplifies code. This is one of the examples where there's code that you need to read, and if, and if, and if. And you can see that actually, when you read this statement, you understand what's going on, and you understand what is returned. So basically, this has been accepted by Guido. And after accepting, it seemed that there came a few issues. First of all, I guess everybody knows what BDFL is. And Guido made there was a furor and a lot of, I would say, emotional responses in the community, some of which Tal described yesterday. And eventually, it made Guido to step down from BDFL with his famous transfer of power email. There was the question, stuff that happened, that people were asking, is he making the right choices, specifically here, because there were a lot of opinionated people who thought things should be different, or whether or not this feature should be included at all in the languages. So basically, this is the acceptance email he sent. He let a very short time for responses. He literally had to ask people to let him get more time to respond because of the amount of emails and stuff that was happening on. And that's the letter, I think Tal also showed it yesterday, the transfer of power, where he says, okay, I'm stepping down, this is it. I think it's time for the community to take the decisions. I don't want to be the one where all the disagreements go to, and people who don't agree feel like I'm doing the right thing and don't like my decisions. I think we are now very big as a community, and we can take it to the next step. And again, as Tal described, there's a steering council. For the lack of time, I won't go into the details, but these are the 5 people elected for the steering council. Okay, I'm moving on to the next features of the version 3.8. As I said, this was the major one, but this equal specifier for f strings, I hope everyone is familiar with f strings because they make our life easier and easy to understand. And as you can see, for debug purposes or maybe other cases, there is a very nice way to look at variables. So you can have something like x equals, and this means for the f strings to include x, the string x, equals, and the value of x, which is stuff we do a lot if we debug using printing. Then we use this kind of stuff, and this simplifies our task, putting expressions or whatever we like, and an equal at the end, and get the result. Another change is an addition, a change in the way we define functions. There's a new delimiter, which is the slash. You can see it here. And the slash gives us the ability to have positional-only parameters, which means we cannot use keywords to describe them. For example, in this case, there's a function, and you can only transfer numbers. You cannot transfer like keyword arguments to it. You have to transfer only numbers. There are a few use cases for this, and those who want go are welcome to look at PEP 570, which describes these features and everything related to it. The new formal way to do functions is now using first the positional-only parameters, then the slash. These are obviously optional. You don't have to do that. You can skip them. But if you do, you have to put them first. Then positional keyword parameters, which is the normal way we do in Python. And after the second delimiter, the asterisk, we can have the keyword-only parameters, which mean we must use keywords to be able to transfer parameters there. Okay, so a few more stuff which is new, but it's only for people who are really into the details. One of them is the ability to change the location of the cache files. As you know, today it's within the same folder from which we run the code, or we have the code, and now we have the ability to change this location. Don't go into the details. There's a clear discussion and details in the documents, but the idea is we don't necessarily want to have, by the way, that's the way it's defined. We don't have to do this in the current directory. It can be anywhere else. Okay, I don't know if, does anybody here know what ABI is? Anyone? Whoa, okay, a few. The good news is that now release and debug use the same ABI, which means they have the same interface, and you can use them together. So you can describe, and the only incapability that was before them, before union them, is fixed. So now in order to do it, you can see here the difference for those who understand. If we want, you can come to me later. For lack of time, I can't really go into these details. Another important feature is the initialization configuration. Python would start even faster, and there's a new C API and a finer control of stuff, which means that stuff can be done and implemented better. In the last maybe 2 minutes, I'll just mention a few of the stuff that I find very useful in previous versions. I guess some of you are familiar. Well, obviously the data classes, which were from 3.7. The f strings, which I mentioned earlier, had some improvement here. Type hints for those who want their functions to be more documented and typed, and enable the IDE to assist in identifying issues and bugs. The coroutines and the whole async I/O and the ability to run stuff concurrently. Matrix multiplication using the strudel sign. Passlib, working with files, enumerations, and one thing I really like in Python is the language is changing, it's moving, it's becoming more friendly, even more than it was before. It's already was very friendly, but I think the ability to move on and do stuff that enables us better life is amazing. Last one is enumerations. Okay, any questions? The question was, what's the scope for assignment expressions? The answer is you can always close them in parentheses and then you have exact scoping. There are minor issues related to the scoping because of the way it's implemented, but basically first the assignment expression, the part that you look into, you can close that in parentheses and then you verify which part is going into the assignment. Otherwise, if you do an assignment in an if statement and then end something, it might be that the end is part of the expression that is assigned. That's one point. The other point is the other way around, where we can use this kind of variable. So we entered a new variable, let's say the match that I showed before, and this match has a scope which is like it was defined in the statement before the place where the expression is. Obviously, within the same statement, you can only use it in a place which is logical, and obviously here it's kind of very native to understand. If you have an if clause in a comprehension, you cannot use in the if clause something which is created in the comprehension result. Okay? Okay, everyone, thank you very much.